later. Alrighty, so the first question is actually pretty easy. It's not even a question. You just have to describe how you do something. So, well, I mean, I guess that is a question, but it's a directive more. Chapter 3, Problem 1, 3 and 1. Okay. So, all it is describe how you would use a single array to implement 3 stacks. That's it. So the equivalent of an array in Clojure is a vector. And I guess, I mean, you'd never do this. Like, if at minimum you would use a map, right, to hold 3 separate stacks or something, you know, but if you had to use a single array, I guess we'll just write out the thing. Implement 3 stacks. I mean, I guess you could have I guess you could use the first. You could say that the first cell and that is, or this the you know this is the cell index and this is the description. And so at index 1 you would have a count of the number of stacks in this array. Number 2, you might have a well, actually it's be more like 3 times 2. Each 2 elements list starting index of and size of each stack. Alright. Right. So I need to know the number of stacks within this array, and I need to know the within here. I guess let's just call this array metadata, right? And it's going to be 2 elements. And you could know, because you know the size of the metadata, you would know how many of these you expect. So if you had 3 arrays, you'd have the first element would be the number 3, and the next 6 elements, right, 3 times 2, would be metadata about the 3 successive stacks, where for each stack, where stack index and stack size, right? I think with a stack index, that is the location where the stack root starts from. Oh, you can, yeah, with the stack index and the stack size, you can, yeah, I think that's pretty much all you minimally need to do a, because you're gonna, I mean, the stack index basically never changes, right? Let's say the stack location. Right, and the stack size does change as you push and pull things from the stack. Push and pop things from the stack, I should say. Right, so this number is changing as the stack is increased or decreased. You technically need to know capacity of the stack. You could put that here as a third argument, but there's no There's no actual need to, because it can be derived, I think, from this information. If you know the stack index and you know the number of stacks, then I guess it just makes sense. Stack capacity, you know. So in our system, we'd be using one slot to tell us how many stacks there are, and then we'd use the number of slots times 3 to just get this information: the stack index, the stack size, and stack capacity. So your size shouldn't go over your capacity, for instance, right? And other than that, remaining space is used for the 3 for the respective stacks. I mean, I think that's sufficient, right? Interesting thing about, well, it's not really interesting, but I guess with a vector stack, you don't actually have to clear out the data, right? Because you have a fixed size stack, a maximally sizable stack, you just leave the data there if you want. You don't really need to clear it out, which could be pretty efficient in terms of not forcing garbage collection, right? You wouldn't really force garbage collection. Well, first of all, if you actually have primitive types in there, right, things that literally fit within the array, that are directly in the array, which is, since you're putting, I guess these are all integers, right? If you're putting integers in the stack, then you actually have a thing that does not have any heap allocation, which is obviously is going to be much faster, I would guess. But assuming you have a sort of, maybe that's what they're asking. I don't know. No, I'm going to assume that it's an array of references, right? Or it's just one of these newer generic arrays, like vector. Well, vector's not really like an array, but so it can hold anything. It can hold non-homogeneous things, and so yeah, it's it just depends. But you could get it to the point that it's, yeah, well, who cares? So anyway, that's probably what I would do. Yeah, that's really not much to say about it. 3 and 1. Okay. Oops, let's copy this out. Oh, or failure here. I forgot. That's weird. What is this doing? Alright, Alt W. Command. Control. Alright, problem 3.1. See if we can make this. How do you hyphenate shorten addition? E. Make it a little less long. I think that's silly. Yeah. Alright. Stop messing with it.